In this video, we're going to practice dividing whole numbers by decimals. My first example says 1 divided by 4. So that means I'm going to have one object and divide it into 4 groups or 4 pieces. Now, you may start off thinking that one object can't be split into 4 pieces, but I know that if I have $1, I can break that up into 4 coins. So initially when I see 1 cannot be divided by 4, I'm going to add a decimal and some zeros. And the first thing I'm going to do before I start the problem is I'm going to go ahead and put the decimal on the roof. Now I'm going to ignore my decimal and divide just like I normally would. 4 cannot go into 1, so I can put an X or a 0. But if I scoot over and look at the next number behind the decimal, this number now looks like 10. So I can think of it as like 10 dimes or in a dollar. When I'm using the 0 behind the decimal, this tells me that my answer is also going to go behind the decimal. 4 can go into 10. It can go into 10 2 times. Now I continue my steps just like normal. 2 times 4 is 8. Divide, multiply, subtract. So now what is 10 minus 8? Well, that's 2. Divide, multiply, subtract, bring down. Now I'm looking at 4 going into 20, and I know that 4 can go into 20 5 times. So my 5 goes right above the number I just brought down, and 5 times 4 is 20. When I subtract, that is 0. And if I wanted to, I could add another 0 and just keep bringing them down, and I know my next answer would be 0. So 1 divided by 4 is 25 hundredths, and I know this makes sense because if I have $1, I can break that up into 4 quarters. Now, to check that I'm correct, I'm going to go to the side, and I always check division with multiplication. So I'm going to say 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 0 is 0, plus 1 is 1. And when I'm multiplying, I know I need to count how many numbers are behind the decimal. So there are 2 behind it in the problem, which means there needs to be 2 behind it in the answer. And $1 is what I started with. So $1 divided by 4 is worth 25 hundredths. Our next example is 13 divided by 2. So 13 goes under the house, and I'm going to divide by 2. I know that 2 cannot fit inside of 1. 2 can go into 13. It can go in 6 times. 6 times 2 is 12. So I divided, I multiply, now I'm going to subtract. 3 minus 2 is 1. Now, normally my next step would be to bring down the next number. In 4th grade, you would have called this a remainder, but with decimals, there are no such things as remainders. So I'm going to do what I did in the first problem. I'm going to add a decimal and some zeros. And I'm going to go ahead and add this decimal at the roof of the answer. So when I go to bring down, I'm going to bring down the 0. Because 0 came from behind the decimal, I know that my answer is also going to be behind the decimal. Now I can divide just like I normally would. 2 can go into 10 5 times, and 5 times 2 is 10. When I subtract, I get 0, and if I were to bring down the next number, 2 can go into 0 0 times. So now that I'm left without a remainder, I can stop. I always check division with multiplication. And you can use 6 and 50 hundredths, or you could check with 6 and 5 tenths. It should give you the same answer either way. 2 times 0 is 0. 2 times 5 is 10. 2 times 6 is 12, and 12 plus 1 is 13. Now I look to the problem. There are 2 numbers behind the decimal in the problem, which means there are 2 numbers behind it in my answer. And I got 13, which is what I started with. And I like to think about this as money. So if I had $13 and I wanted to divide it between two people, each person would get $6, and then I would take my last dollar, break it into quarters, and each person would get 50 cents. I can also use estimation to help guarantee that my answer is correct. 13 divided by 2 should be somewhere around 6 because I know 12 divided by 2 is 6 and 14 divided by 2 is 7. So it makes sense that my answer should be somewhere between 6 and 7. Now let's try division with numbers that have whole numbers and a decimal in them. So I'm going to start just like I would with the other examples. 20 and 75 hundredths divided by 5. The only difference between this example and the previous ones is that the problem has already given me a decimal. So I can go ahead and bring that decimal to the roof of my problem. Now I'm going to divide just like I normally would. 5 cannot go into 2. 5 can fit inside of 20. It can fit inside of 20 4 times. 4 times 5 is 20. When I subtract, I get 0. When I go to bring down my next number, I notice that the 7 is behind the decimal. So it's kind of like going to the dark side. Once I've started pulling numbers from behind the decimal, my answer should also start going behind the decimal. 5 can fit inside of 7 once. 1 times 5 is 5. 7 minus 5 is 2. And now I bring down the next number. 5 can fit into 25 evenly 5 times. 5 times 5 is 25. And when I subtract, I get 0. Because I have arrived at 0 and there's no other number behind it for me to pull down, I can stop my problem here. If there were a remainder, I would go ahead and add zeros behind the decimal and continue to pull those zeros down. Now let's go to the side and check it with multiplication. So 4 and 15 hundredths times 5. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. And 5 times 4 is 20. Now I'm going to look at the problem. There are 2 numbers behind a decimal in the problem, so there should be 2 behind it in the answer. And 20 and 75 hundredths is what I started with, which is how I know my answer is correct. Our next example also already has a decimal in it. So 104 and 22 hundredths divided by 6. I'm going to immediately go ahead and put my decimal in the roof, so I know that there is going to be a decimal in my answer. And now I divide just like normal. 6 cannot fit into 1, but 6 can go into 10 one time. 1 times 6 is 6. When I go to subtract, I know that 10 minus 6 is 4. And after I subtract, I bring down the next number. Now this number is in front of my decimal, which means my answer will still be in front of my decimal. 6 can fit inside of 44. It can fit inside 7 times. 7 times 6 is 42. 4 minus 2 is 2. 4 minus 4 would be 0. So after I subtract, I bring down. Now notice that this 2 did come from behind the decimal, which means my answer will now start going behind the decimal in the 10th place. 6 can go into 22. It can go in 3 times. 3 times 6 is 18. I know 12 minus 8 is 4. 1 minus 1 would be 0. So I'm going to bring down my last number, 42, and 6 does evenly go into 42. I did that earlier. It can go in 7 times, and 42 minus 42 is 0. So because I do not have a remainder, I can stop here and check with multiplication. Six times 7 is 42. 6 times 3 is 18. 18 plus 4 is 22. 6 times 7 is 42, and 42 plus 2 is 44. 6 times 1 is 6, and 6 plus 4 is 10. And my last step is there are 2 numbers behind the decimal in the problem, which means there are 2 behind it in the answer. And I got 104 and 22 hundredths, which is what I started with. Try these 4 problems to practice division with decimals. At the end of the problem, you need to check it with multiplication to make sure that your answer is correct. Remember, if it's a whole number, all I need to do is add a decimal and some zeros, and I want to make sure that I'm carrying my decimal to the roof of the problem in all of these examples.